Okay, are you guys able to see my screen, guys?
Yes, sir.
Okay, cool. So, yeah. Rachit, Sana, Snigdha, turn on the videos, please. Neve, can you recap for me? Where did we last stop, last class? Which problem? Did we finish
So,
question 4?
no, sir, we finished question 3.
We finished question 3 or other variants of this. Okay, let's start with question 4 then. I'm pasting question 4. Rachit, we're able to do question 4.
One second, sir. Yes?
Question 4 on the screen. Were you able to do this one?
No, sir.
I mean, as in you tried but did not get it.
Yeah.
Okay, cool. Saurabh, what about you? I don't see you either. Saurabh, video on.
Yes. So question 4, right? Last week's one.
Yeah.
So I got radius as 2.
Radius is 2. Okay.
Yes.
All right. Gyan, how about you?
So I did not get this sum.
Okay. Any other answers, guys? So Neve got not Neve. Saurabh got 2 as a radius.
10 by 15.
10 by
13 or something
Yes,
like
sir.
I'm not able to hear you fully, Akshay. One more 10 by
10 by 3. 10 by 3.
10
So
by 3.
actually, even I got 10 by 3. I don't know why I've written 2.
Okay. All right. Okay. So let's quickly do it for those who did not get it. Okay. So this is the radius. I mean, this is the center. I'm sorry. Let's say this is the center. I'll mark it. This is D. Okay. So let me mark. Whenever there's a circle, there's a tangent. The very first thing you should do is mark the line that's connecting them so that you know that this line is perpendicular, right? The tangent is perpendicular to the radius. So this is R. This is R. And because this is given to be a right angle triangle, you know 5, 12, and 13 is a triplet. So this is 13. So we know that this length from here to here is 13. The way from here to here. So suppose this is R. Okay, so first of all, from the external point B, tangents from an external point to a circle will have the same measurement. We covered this in the past. So let's, if I have a circle here, any circle, if I have an external point here, if I draw 2 tangents, let's say the first tangent is this, and the second tangent is this. These 2 tangents will be of the same length. Okay, so why will they be of the same length? So let's say this is the center, and if I connect them to the center, okay. So this is the tangent and the radius are perpendicular. So this is perpendicular as well. And if I connect this from this external tangent point to the center here, okay. So let's label all of this. Let's say the center is P. Let's say this is Q, R, and S. So now the 2 triangles PQR and PRS are congruent. PQR and PRS are congruent. Neve, can you tell me, is Neve in this batch or some other batch? I forgot. Neve, yeah, there you are. So PQR and PRS are congruent. Can you tell me why they are congruent? By what property, like SSS, SAS, and all that?
I don't know.
Okay, give it a shot. No, don't give up quickly. So there are 2 triangles. You know there are only a few different categories, right? For congruency, SSS is one, SAS is another.
Wait, so shouldn't it be PQS and PRS?
PQS and PRS. What have I written?
PQR.
PQR. Sorry. PQS, of course. Sorry. Yes. So what are the different congruency? SSS, SAS, ASA, and then we know ASS is not a property for congruency, just to recap. But then in a right angle triangle, we have RHS. So RHS is like ASS because R stands for the right angle. Hypotenuse is a side, another side. So in a way, RHS is like ASS. But ASS in general will not be valid, but specifically for a right angle triangle, ASS is valid. That's the RHS property. So these are the main congruency properties. So Neve, come on, I'll help you. Show that these two are congruent. Let's start with something. Make a start.
So they both have right angles.
Correct. So both are right angles. Okay, that's good.
So their sides are equal.
Which sides are equal?
So RS and QS.
That's what we have to prove eventually. We don't know yet that they are equal, right? But there are some other pair of sides which are equal. Okay, Sana,
So there
can you?
can be one
Yeah.
more 90-degree angle, like where PS, that line, that can be 90 degrees.
There's only 190, right? In any triangle, there's only one angle which is 90, right? How can another angle be 90?
Oh yeah.
Yeah, Sana, can you continue from here?
I think it's SSA. Sorry, no, not SSA.
First, let's call out what are, or Akrit, you don't have to raise your hand. I'll make sure everyone gets a chance. Don't worry about it. Yeah.
The
yeah.
things that are congruent are the two 90-degrry angles.
Yeah. What
Then
else?
both triangles share the hypotenuse.
Yeah.
So
So
it's
this.
the exact same.
So the PS is common, right? Do you agree?
Yes,
The side PS is common.
And because the radius would be the same no matter where in the circle, the radius is also the same.
Yeah. So PQ equal to PR. Does it make sense, Neve? So therefore, by what property are these two congruent, Sana?
RHS.
RHS. Yeah. So it looks like ASS. Technically, if you look, there is the angle which is 90 degree, and then one side which is common, another side which is the radius. So technically, it's ASS. ASS is not a theorem for proving congruency, but like I said many times, the only special case for ASS is RHS. The angle happens to be a right angle triangle, and one of the sides happens to be the hypotenuse, and another side, whatever side, then it works, right? Therefore, these two are congruent, and therefore I can conclude that this, from the external point S, the two tangents are of the same length. Does it make sense to everyone? Snigdha, you're with me?
Yes.
Okay. Therefore, if this from B to C is 5, this also should be 5. And therefore, let's call this point E or something. So if BE is 5, then the rest of it is AE is 8. Now, in this triangle AED, we can use Pythagoras theorem, right? So Rachit, you're with me so far, right? So 8 square plus R square becomes the hypotenuse square. So Rachit, can you tell me what AD would be, the hypotenuse?
So AD.
Yeah, that's for the hypotenuse, right? For the triangle AED.
It will be square plus R square. So I don't know.
No, you do know. Don't give up, guys, so soon. So this 12 is from here to here, right? So 12 is from here to here. So AD is what? Yeah, Gyan, go ahead.
So is it 10?
AD is 10, you're saying?
Yes, sir.
Why?
So Pythagorean triplets.
Which Pythagorean triplet? 8, 6, and 10 is a triplet, but we don't know what R is. Yeah, Akrit, what is AD?
So I don't know, but like you can say that 10 is wrong because then R would be 6 according to the triplet, but then 10 plus 6 is 16, so it's not 12. So you can say that's wrong.
10 plus 6 is?
10 plus 6 is 16.
And what's wrong with 16?
AC is 12. So that's why you can tell like that.
AC is 12. Ah, okay. Yes, that's a good point, right? If R is 6, then yeah. So his point is, if you say the radius is 10 and then R is 6, there are a couple of places by which you can infer that's wrong. Yeah, that's a good one, Akrit. Okay, yeah. Who can tell me? Snigdha, what is AD?
I have a question.
Okay, Sana, go ahead.
Could you say 12 minus 2R?
12 minus R, not 12 minus 2R.
2R.
12 minus R, not 12 minus 2R.
No, sir, 12 minus 2R.
12 minus 2R would go till this point. Let's say this is AF. AF would be 12 minus 2R. But AD is 12 minus R, no?
Yeah, I thought like as in this, the part which is not counted in the circle.
Yeah, so everything is labeled precisely, right? AD is AC minus CD. So this is AC minus CD, which is 12 minus R. Agreed, Sana? Okay. And now from here on, it's just 12 minus R whole square, sorry. All of you okay with this one? This Pythagorean, Neve, you're okay with this one? You're seeing how we are getting this? Sure, right? Now we can just expand. So 64 plus R square equal to, Snigdha, can you mute your phone because it's noisy? Yeah, 144 A minus B whole square, right? Minus 2AB, 24R plus R square. So R square get cancelled. Let's say 144, I bring it to the side. So 144 minus 64 is this. And therefore R is 80 by 24, which can be simplified. 8 goes 10 times, 8 goes 3 times. 10 by 3 indeed.
So I got the same answer, but I did it in a slightly different way.
Go ahead, Arnav. Can you explain what you
I
did?
did the small triangle and a big triangle, like the relation you had taught us.
Similarity. Okay.
Yeah,
Which
I did
small
that.
triangle in this case? AED and the ABC.
So basically what I did was 12 minus R divided by R is equals to 13 divided by 5.
Excellent. Excellent. Okay. Does everyone understand what Arnav is doing? So Arnav is using similarity. So this is one way. Now he is using similarity.
So, but which angles are similar? Like the 90 degrees is there, but then how do you know the other one?
Yeah. So so the two triangles are AED and ABC. Okay. So let's see what is common. So we have that angle A is common to both, which is theta in both. Okay. So there is a theta. There's a theta here as well. There's a 90 and there's a 90 here as well. So obviously the third one should match 90 minus theta, which in this case is this, will match. I'll just, since there's too much clutter, I'll just mark it with double, right? And then the 90 minus theta in this case would be this 90 minus theta. Right. So all of you with me on this one? What Arnav has done. Now he knows in the big triangle, ABC, let's put the sides corresponding to the one opposite to theta in the big triangle is 5. The one opposite to 90 in the big triangle is 13. The one opposite to 90 minus theta in the big triangle is 12. Now in the small triangle, which is AED, the one opposite to theta is the R that we are seeking. The one opposite to 90 is the 12 minus R. The one opposite to 90 minus theta is the 8. Okay, now we can do it in multiple ways. You have to solve for R, right? So we can choose either, I can say this upon this is this upon this. So matter khatam. So I can just say 8 upon R equal to 12 upon 5. Yeah, and that's it. So R is 40 upon 12. So 4 goes 10 times, 4 goes 3 times. He did something else. He did 12 minus R upon 8, I think, whatever. You have multiple ways to do this. But are you all of you guys comfortable with similarity? It's a very good, Arnav, that you're trying to use what we learned earlier. Yeah, whenever an opportunity presents, use similarity of triangles, do it. And whenever there's a right angle, almost always there'll be some two triangles which are similar. Because एक तो हो गया, एक 90 तो हो गया, और मुश्किल से एक और हो जाएगा, then the third one will obviously be 90 minus that. So whenever there's a couple of right angle triangles, look for opportunities to exploit similarity. Snigdha, are you with me? Saurabh, are you with me completely?
Yes, sir.
Okay, did anyone not understand this, both methods? Akshad, you're with me?
Yes, sir.
Okay, all right, extra question for all of you. Find the length BD and do some basic sanity check, or any sanity check you can do to convince that seems right. No calculator, find BD. You can express your answer in square root of something or fraction. You don't have to give decimal answer.
Sir, it's root 325 by 9. So it's root 325 divided by 3.
Okay. Any answer, guys?
And
Okay.
sir, if we, yes, sir. Sir,
Okay. Yeah, Gyan
Yes,
has
sir.
pinged me an answer. That's fine. I'll put it up here, Gyan. 1 second, Arnav.
Yeah.
So, okay, Gyan. So square root of the whole thing, you mean, right? So Gyan gives me this. Okay. Okay, which I would like to write it this way, Gyan.
Sir, I've got the same answer, but I've simplified it even further.
Okay, tell me what that
Got,
simplifies to.
5 root 13, the whole divided by 3.
Yeah. So basically what he has done is, this is 25 times how much? 25 times 4 is 100. 300 has 300s, right? The 3 into 4, 12 25s, and then an extra 25 to make it 325. So he has brought the 25 out as 5 times root of 13 by 3. Okay, so both these are, so all of these, right? Okay. Now, can you guys approximately tell me what this number is without calculator? Approximately tell me what this value would be. Here is where knowing your perfect squares, perfect cubes, all this comes handy.
So,
Yes.
how do you take the 25 out again?
Because if I have square root of AB is same as square root of A times square root of B. So I can do 25 times 30 as square root of 25 times square root of 30.
But I think it'll come out approximately to 6, I think.
Approximately 6. And why do you say that?
So 30
So-
square root is around 3.6, I believe.
Okay. How do you know 13 square root is 3.6?
They told us to remember.
Okay. 13, I didn't ask you to remember. I asked you to remember perfect squares till 1000. So if you know 36 square, that's great. What is 36 square?
36 square. Don't
Which-
know.
Which is how you got 13 square is 3.6, right?
No. You told me to remember.
Sir,
Yes. Yes, go ahead.
so it'll be 6 point something because 18 square is 324.
Excellent.
So,
That was the answer I was expecting. Yes. So 324 is so close to perfect square. 324 is 18 square. Very well done, Jan. Okay. Therefore, this is square root of 325 is 18 approximately, slightly more than 18. And therefore 18 by 3, which is 6. Okay, that's an easier way. But Arnav, what you said is also fine. 36 square, if you're able to remember, that's excellent. 1296. Yes. Square root of 13 is very close. So because 3.6 square will therefore be 12.96, which is very close to 13. So square root of 13 will be approximately 3.6. But I would have expected this guy's answer, Gyan's answer. That's a much easier one, right? 325 is right on target. 324 say ek jada bas. Okay. And then logically, does it make sense? So approximately 6, if I draw this line as B to T, okay, does this look like 6? Yeah, I mean, does not look like 6 or whatever, but 6 seems not very unreasonable. We definitely know it has to be more than 5 because 5 is the 6 is the hypotenuse in this triangle BCD, for example. 5 is the one of the sides are we formed for 10 by 3, which is 3.33. So something more than 5 was reasonable, but it's not much bigger than 5. Suppose you got the answer is 8 or 9, then you would suspect. Okay, so 6 seems fine, and yeah, this is right. Did anyone not get this answer? 325 by whatever the square root of 325 by 3. Did anyone not get this?
I didn't get it. So how do you get it?
Oh, this is actually no. I don't want Arnav or Jan to say. Can someone else say? Singha, did you get this 325 by thing?
Yes, sir.
Okay, can you explain to class?
Yes, sir. So basically, it root of 325 by 9. 18 square is 324.
No. I'm not talking about the simplification. How did he arrive at 325 by 9?
Yes, sir. So if we draw a line BD,
Yeah.
then the radius of the circle and 5 and the BD form a right angle triangle.
Yeah.
And so then you use the Pythagoras theorem to find BD.
Exactly. Yeah, Akrit, I expected better from you. 5 square plus 10 by 3 whole square. Yeah. What happened?
I didn't see that.
You didn't see that. Okay, cool. All of you see this, right? So BC, CD, I'll mark it as 10 by 3 rather than 3.33. So, okay, BC, CD, and BD. I mean, for a right angle triangle, therefore BD is as simple as this. When you simplify, you get this. Okay, one more last question. What is the length of the perpendicular from C to BD? So this perpendicular, when you draw from here to this. Okay, so let's call this point as, where are we right now? F, can say F. Okay, let's call this point F. Find CF for me. Length of the perpendicular from C to BD. I'll remove all this other clutter. Okay. Fastest finger. I'm waiting for the fastest finger. Whoever gets it first, call out.
So 10 by root 30.
10 by root 30.
30.
Like this. 10 by root 13.
Yeah.
Okay. How much will it approximately be?
So wait,
It'll be around 3, right?
It's a little bit less than 3, right?
Okay. What is your, yeah, a little bit less than 3 or yeah, less than 3, right?
Yeah.
Okay. And lengthwise, it seems reasonable, but sorry, I didn't work it out myself. Let me just, or maybe I was.
25 by 36.
You got 35 by 36.
No, sir, 25 by 36.
25 by 36 without any root. 25 by 36, I saw.
Yes, sir.
Okay, but that's less than 1, right? Definitely by inspection, just by visual thing, you can see it's more than 1, no? CF, see, CD is approximately 3.
Yeah.
So approximately 3 se thoda kam. So I'm willing to take an answer which is 10 by root 13, which is reasonable, but I'm not willing to take 25 by 36. Akshad, you're with me on the visual inspection part.
Yes, sir.
Okay. Yeah. So let's quickly do it. It's fairly easy, right? We have been through this many times. So if I have any right angle triangle, forget this problem. If I have any right angle triangle, I'll call this some other PQR or something. PQR. Let's say this is 90. If this length is R, then this length is Q, this length is P, right? And suppose I have a perpendicular from the 90 degree to the hypotenuse. Okay, let's call this as H. Now, we know the area of the triangle can be expressed in 2 ways. It's half into H into P. It's also half into, if I keep the base as R, the height becomes Q. So half gets cancelled. So the height is nothing but R into Q upon P, or rather the product of the 2 sides upon the hypotenuse. As simple as that. So exactly same thing. 5 is one side, 10 by 3 is another side, and the third side is what we just found, 325 by jo bhi tha wo. 320 square root of BD was kitna tha wo BD? BD is square root of 325, which is 5 root 13 upon 3. Okay, so CF that we are seeking, this is F, is the product of the 2 sides, 5 and 10 by 3 upon 5 root 13 by 3. So 5 gets cancelled. The 3, when it goes over, it gets cancelled, leaving 10 by root 13 indeed. Does it make sense, guys?
So I did a much more complicated and longer method.
You did similarity of triangles and all that?
No, sir, like very, so I found the area of AED and then subtracted from the whole area. So I got the area of BEDC, and then that's a kite. So then I did multiplication of diagonals, half into D1 into D2.
And then divide that by diagonal by 2. But it's great that you were able to do this much in that amount of time. That's great. So yes, well, the method was definitely long. The speed was very good.
So
Okay,
could you
cool.
explain again? Sorry, I just lost you in the middle.
I won't explain, but Jan will explain. Jan, go ahead. My method. Or you want to explain
So-
Akrit's method? Which one do you want to explain?
Sir, I myself was gonna ask you to like re-explain what Arnav asked it. So I said you
Okay,
can.
okay. Sana, are you ready to explain? Did you understand what I said?
About the finding H?
Yes, correct.
Yes, I did.
Okay, yeah. Finding H and then just applying that to this problem. Okay, just describe the generic problem. In a right angle triangle, if the two sides are given and the hypotenuse is given, how do you find the height to the hypotenuse? Okay,
Should
go
I
ahead, Sana.
explain?
Yeah, go ahead, Sana.
Okay, so we covered this when we were talking about the ratio of the right angle triangle. So if we know that the ratio of the hypotenuse to PR was 6:5, and PQR as a triangle is similar to sorry, not PQR, PQ small p.
Oh, sorry. Okay, so small p is actually the side. So I'll label this as S.
Oh,
Okay, so generally small letters are used for the
Sides.
sides and capital letters are used for points. Yeah, go ahead.
so if PQS is similar to the triangle PQR, then the ratio of R is to H, it should be the same as Q is to P.
Correct. But in this case, in fact, that's how it comes. The similarity is also similar. A much easier concept to understand in this case is just equating the two areas, right? Area of the same triangle PQR. Okay. Okay, here I go again once more, guys. Okay, so the triangle PQR ka area, I can derive it in two different ways. That's half into base into height. Gyan, you agree on this one? Half into H into P. Okay, now tilt your head a little bit. Akshaj. Akshaj was the one who was asking, right? Akshaj?
Yeah, I got
Okay.
25 by 36.
Okay, no, how do I get this R into Q by P wala? Who was asking?
No, so I think that was Gyan.
Tough question.
Okay, just 1 second, Akrit, please. Okay, so area of PQR, I'm doing it in two ways. One, using QR as the base. So half into P into H. Another way, if I keep PQ as the base, then the height becomes RP. Do you agree? Do you agree? So half into R into Q. I don't see anyone nodding their head. Gyan, are you with me?
Yes, sir.
Okay, that's it. And therefore, just half cancel. H is R into Q by P. Bus. Right? So in any right angle triangle, the altitude from the 90-degree point to the hypotenuse is just simply the product of the other two sides upon the hypotenuse, which is P. Does this make sense? Okay. And then in this problem, I'm just literally using this. So this is, in this problem, I'll just draw the relevant diagram here. So this is B, this is C, and this is D, right? This we know, and then this is the perpendicular that we are seeking. Okay, just to label all the points correspondingly. This was B, this was C, this was D, and this was F. And we know this was 5, we know this was 10 by 3. And then in the previous problem, we just did, this was 5 root something, right? 5 root 13 by 3. ये हमने निकाला था ये यहाँ से यहाँ तक. And then this was the H that we wanted to find. And just literally applied this 5 into 10 by 3 upon this. Does this make sense, guys? All of you okay on this one now? Okay.
Yes,
Akrit,
sir.
Akrit, what was your question, please?
So I don't know, but I think there's some formula like 1 upon a square plus 1 upon b square, 1 upon h square. I think there's something like that.
Which one? 1 upon a square. I don't exactly follow what you're saying. If you can tell me what the formula is, I can.
1
maybe-
upon a 1 upon the small side plus 1 upon medium side equals to 1 upon the height, the other height, like the one in this. I think there's some formula like that. I saw a video.
Let me just think. 1 upon this plus 1 upon this equal to 1 upon this. Okay, so if at all you're saying that the two heights are R and Q in that case. So 1 upon R plus 1 upon Q becomes Q plus R upon QR. That is not 1 upon H.
No, so like 1 upon r squared plus 1 upon q squared.
Okay. I see. So what he's saying is 1 upon r square plus 1 upon q square is 1 upon h square. That's another way of writing the same thing. Okay, that's because if you simplify this, so r and q are again this right angle triangle, right? So this is, by the way, this is small p. I don't know how to denote small p. Let's say this is small p. Okay, so 1 upon r square is, so I can take r square q square as common denominator. Here upar r square plus q square ho jata hai, right? So in fact, I'm not even going to say 1 upon h square. We'll prove it's that. But r square plus q square is your p square, which is the hypotenuse, not hypotenuse, p square upon r square q square. Okay, which is p upon rq, the whole square. But we know that we just saw by this that h is rq upon p. So this is nothing but 1 upon h whole square. Okay, same thing, just coming in another flavor, that's it. But it's much easier to do r into q upon the hypotenuse p. But what you said is also right. Good, thanks for sharing that. Okay, everyone good or more confused or less confused or completely clear? Saurabh, you're with me? Good. Sana, you're okay. Snigdha, Neve. Okay, cool. That was this question. Question 5. Snigdha, what did you do on question 5 for me?
So I couldn't solve question 5.
Why not? It was not a difficult question. Did you give enough time?
Yes.
How much time did you give on it?
I don't remember.
Huh?
I don't remember exactly.
5 minutes diya?
Huh? Yeah.
You gave 5 minutes. Okay. So, okay. All right. I'm just being hard on Snigdha, but my point is all of you should give enough time and then you should be able to figure out. Yeah, Neve, go ahead, please.
Is it 361? I think I got an answer of 361.
Okay, go ahead, explain. So 361 is his answer. Okay, fine, go ahead.
So in the like I don't know how to explain, but like so there are 37 tiles. So
Yeah.
then one tile will be shared by like both the diagonals because it's an odd number. Like in an even number,
Yeah.
there will be two different diagonals, but in the like the odd number, one tile will be shared by like two diagonals.
Yeah. So just so that.
So then I did 30.
Just 1 second. So yes, just to explain what he said. So if it's an odd, like I've drawn a 5 by 5 here. So this one middle piece is shared between this diagonal and the other diagonal. Okay, go ahead now. So, and that happens in an odd by odd wala square. Okay, Neve, continue, please.
So then I did 37 equals 2x plus 1. I got a 38 equals 2x, x equals 19, and then I squared it.
Okay, so he said that, sorry, why am I not getting this? So he said 37 is 2x plus 1. What is this 2x and what is this plus 1?
So like just to not recount the
okay,
like
then
the
it should be
shared
2x
tiles.
minus 1, no? Why 2x plus 1? 2x plus 1 or 2x minus 1?
It should be 2x plus 1.
If you're getting counted twice, then should subtract 1, no? Not add 1. What is x according to
It's
for
2x minus 1.
yeah, but depends on what your notation is. What is your notation? What is x according to you, Neve?
Oh yeah, so wait, yeah, it should be 2x minus 1. Plus
Okay,
1.
but what is x? Just for explaining to class, what is x?
I don't know how to explain x. So.
No, come on. If you're writing something, then you should be able to know what your variable is. What do you mean? I don't know how to explain x. What is x in what you are, your own working? What is x? That's all I'm asking. Guys, sorry, I'm being hard on you guys. Okay, if you guys put down something on your paper, for every variable that you have, you should be able to tell what that means. Otherwise, how do you expect me to make sense out of 37 equal to 2x minus 1, Neve? So I know you know it. You're just fumbling to answer. No. Put down your hand, guys. It's okay. You don't have to raise your hand. I'll make sure everyone gets a chance. Don't worry. Yeah. So help me here, Neve. So 2x minus 1. Yes, you're right that this common piece is shared. Okay. Continue. Let X be the number of squares on any one diagonal. Then, so X is squares in one diagonal, let's say. Okay. Therefore, you have 2x. There are 2 of them. But then this square is getting double counted. And therefore, you wrote 2x minus 1. But you should be able to explain this, Neve. Okay. It's not enough to write it. You should be able to explain it as well. Yes. And therefore, can you continue? X equal to 19. Okay. After that.
And then we squared 19 square.
But X is the number of squares on the diagonal. What does that have to do with the side length itself?
So because then like you want to count like the total number of squares in that box, so then I think you do 19 square.
No, I agree. But the X that you counted for me is the number of squares on the diagonal. What does that have a relationship with the number of squares in the entire grid? What is the connection? Okay, Snigdha, can you continue from here?
So I think since it's a square, we can use Pythagoras theorem.
Okay, Pythagoras theorem, and do what? Go ahead.
Yes, sir. So
continue. So far you agree with him that there are 19 squares on the main diagonal, on one of the main diagonals.
Yes, sir.
Okay, then what would you do after that?
So basically root 2a will be equal to 19, right?
Okay, so this length is A, this
If
length
A
is A.
If
So
A is the number of tiles on the side.
Okay, so A root 2 is 19, you're saying.
No, root 2a, right?
Okay, which is A root 2, no? Root 2A same as A times root 2, right?
Oh, yeah.
Yeah, and therefore you're saying A is 19 by root 2.
So is it?
So sorry, just once. Sorry, Neve, you're saying something? Go ahead.
So I'm not sure about this, but so you can see when you draw the grid because the diagonals on the sides are same.
Sorry, one of you, Snigdha, hold on just 1 second. Neve wants to complete what he said. Yeah, continue, Neve.
Is it because the I'm not sure, but is it because the diagonals on the sides are same on the in the square?
Are they same? Isn't the diagonal longer than the side length? By what she was saying, it's Neve. You can clearly see the diagonal is longer. And if this is A, as she rightly said, this is A root 2. So according to you, A root 2 is your 19. So A should be 19 by root 2, right?
Yeah, but not like the diagonals, but like the squares on the diagonals.
Now you're talking. Yes. And that's what probably Snigdha was also trying to correct herself. The number of squares on the diagonal is the same as the number of squares on any one side. So we are not interested in the length of the diagonal itself, but the number of squares on the diagonal, which is same as the number of squares along like one direction. And therefore, if there are 19 in this direction, there'll be same 19 here also. Okay, Snigdha, you're with me? Is everyone with me as well?
Yes.
And therefore, it's 19 into 19, which is 361. Okay. Does it make sense to everyone, guys? Is everyone okay? Okay, Akrit, did you have something to say in between, or is it Akshaj? Someone's hand was up, or we're just waiting to answer this one only. Okay, all right. Now, here is a question, right? All of you clear on this one? Saurabh, I don't see you better. Turn on the video. And why do I have to tell this? Why is your video not perennially on? Why do you have to switch off the video without informing me? Saurabh Davar? I don't know where he is. Okay, all right. Guys, can I ask an extension question? All of you clear on this one? Solid. Rachit, you're okay? Okay, all right. So I will say, okay, a square-shaped floor is covered with congruent square tails. Okay, and I will say, okay, only the first part of the sentence. Square shape is covered with congruent square tiles. Okay, each each side has b squares. So in our example, b was 19, right? Okay, and b is odd. B is given to be odd. Okay, find an expression. Find an expression for number of squares that are not in the main diagonals, the two main diagonals. Okay, so is the question clear? So I have a square grid, B length, and just like a chessboard is a 8 by 8, this one is a B by B, B cross B, where B is an odd number. And then in terms of B, I want you to find an expression for the number of squares that are not on the main diagonal. मतलब ये और ये छोड़ के बाकी this may, if you count all the squares, how many there will be in terms of B. Don't call out your answer, guys. Akrit, don't call out your answer. Chat me if you have one. Okay, question clear to everyone, I suppose. Yeah, Akrit, chat me if you have it. No, Akrit, you have made a mistake.
So I'm not messaged you anything.
Oh, Akshay just messaged something. Akshay, you have made a mistake. Nyan, no, you have made a mistake as well.
So I said,
Akrit, your answer is right. Sana, your answer is right. Very good. Okay. Yeah, actually, it's very simple. We just discussed this. I just want you to just generalize an expression. 30 seconds more, and then we'll discuss. Oh, sorry, I didn't intend to erase this. But and can you guys simplify? Whoever wrote out the correct answer, can you simplify it better?
Sure, I sent you one more answer.
Even I sent you another answer.
What do you mean another answer? Arnav, I got only one answer from you, and that is wrong.
Yes, I just wrote it wrong, my bad. 1 second.
Okay, and then someone else told me they've sent another answer. What is that? I haven't. Okay. Akrit, your answer is exactly same as what you wrote earlier, I think. No? But you can simplify that. Okay, all right, let's discuss, since many of you have got it right. So as we just discussed.
so B minus 1 whole squared. Is it that?
Yeah,
Simple.
yeah, exactly. So this is B, this is B. So we know the total number of squares is B square. And then we are subtracting the main diagonal. This main diagonal has B. The other main diagonal also has B, right? So it's tempting to subtract B plus B, but then we realize we are over subtracting, as in we are over counting the central piece. Therefore, it's B plus B minus 1 is what we should subtract. Therefore, it becomes B square minus 2B plus 1, which is indeed B minus 1 whole square. And in the problem that we just saw, we saw it was a 19 by 19. 19 by 19 kitna tha? 361. If you subtract the 37, let me erase this. If you subtract the 37, that gives the other pieces, right? Which is 324, which is indeed 18 square, as my good friend Jan will tell me, 19 minus 1 whole square, right? Does it make sense? You can see this apply here. All of you good? Rachit, you're okay on this? Exact same question. Repeat the same question, that B is now even instead of odd.
So we can even use this as a
So
formula.
B squared
Yes.
minus 2B.
Yeah, Akrit, that's right. Arnav, yes, but please, I would have appreciated if you had chatted me, Akrit, so that there's some people, you can some time for others. But Arnav, yes, you're right. You can use this as a formula. Yeah.
So it's basically like just removing a row and a column.
Exactly. So it's B square minus 2B. Here, there's no overlap at all. Therefore, there's no extra removing that minus 1 or whatever. So it's just simply B square minus 2B. Okay, does it make sense, everyone? B square minus 2B. Earlier, it was B square minus. So the only difference was with odd, it was B square minus 2B minus 1. With even, it's just 2B. So this is for even. and this is for odd. Only difference was this. Okay, does it make sense? Okay. All of you good? Snigdha, you're okay? Okay. Now,
Yes.
one more extension. No matter whether B is even or odd, prove that the number of squares that are not on the main diagonal, whatever expression that we are finding, will always be a multiple of 4. So prove that this expression that we found will always be a multiple of 4, irrespective of whether B is even or odd.
So, can you prove it just by like saying, this is why, or do you have to like give a formula or something?
I'm okay with an intuitive proof as well. I'm okay with a for. Okay, go ahead, Sana.
So,
Okay, thanks, Akrit. Okay, Sana, go ahead.
so as you can see, when you divide the square into 4 parts diagonally,
Yeah.
all 4 parts are the exact same.
Excellent. Yes. So that's exactly what the intuitive answer is what I was looking for first. Yes. So what she's saying is no matter whether it's an overlap or non-overlap, jo bhi ho, there'll be 4 symmetric pieces. And whatever the number of squares, essentially in any one of them, I don't care what their expression is, what she's saying. Times 4 is the answer. Therefore, it will be a multiple of 4. Right, Sana? That's what you're saying?
Yes.
Good. Algebraically, can you guys prove it? Akrit, you said you sent me something.
I messaged the same thing in chat.
Oh, you did as well. Okay, great. Thanks, Akrit. Yes, because diagonals will bisect into 4 equal parts is what he said. Good. Okay, now, algebraically, can you prove it as well, guys? Is everyone clear on the intuitive stuff? Snigdha, are you around or have you gone somewhere? Okay.
So I'm here.
Okay. Yeah. So intuitively, Gyan makes sense. Rachit makes sense intuitively. Okay. Now algebraically prove it.
Sorry, sir, I was just thinking and I forgot the answer question. Can you repeat the question once more?
I will not. Akshad will repeat the question. Akshad, repeat the question for Arnav.
So basically, since we found the formula of the squares that is not in the main diagonals, we need to find out how they are divisible by 4, no matter if B is odd or even algebraically.
He didn't explain it well. Yeah, almost right, Akshad. So Arnav, all I'm saying is this number of squares that are not in the main diagonal, prove that no matter whether B is even or odd. Jan, you have something? Your hand was up for a second. No? Okay. Rachit, any idea? But you guys can convince yourself, right? Take an even number, take an odd number. In both cases, it works. Akrit, 1 second. I want to give someone else a chance if possible.
Sure, it is. Sorry, 1 second. Sir, I think I can prove it.
Okay, try Arnav. Akrit, you can put down your hand. Don't worry. I'll give everyone chance. Don't worry. Arnav, yes. Go ahead.
So the formula for even is B square minus 2B, right?
Yeah.
So if you take B out common, you
Yeah.
get B into B minus 2.
Correct.
And
Agreed.
I think if you take any number, it will like you take any number, let's take 2. So then 2 into so no, like not 2. Let's
Take
take
12. 12
Yeah.
into 10.
So 12 into 10, which is 120. 120 is divisible by 4 because
You're-
1 is even.
Yeah, you're observing that with one example, it works. But I'm asking why. Yes, you're almost right. You're almost there. You took the correct step, b into b minus 2. And then you took one example and you're verifying, but Akrit, put on your hand, don't worry. Okay. But Arnav, I want you to finish it. It's b and b minus 2. Just one more step. You have to go from there. Sana, can you complete it for Arnav?
So, if it's B and B, that means it's almost nearly 2B, and then you're subtracting.
If it's b and b, then it's not b 2b, it's b
So,
squared, no?
I got it.
Go ahead, Arnav.
So this is if B is an even number, right?
Yeah.
So B is an even number. B is some even number. And B minus 2 will again also be a multiple of 2. So then 2 into 2, let's just take 2 into 2, will
Excellent.
be 4.
Exactly. Yes.
Okay.
So you have an even number
Maybe
b.
I can't explain it properly, but I
No, that's
think
right. You explained that very well. So b is an even number, therefore it has a 2. B minus 2 is an even number, therefore it has a 2 buried in it. Therefore, when you multiply, it will have 2 into 2, 4 buried in it. Does it make sense, Sana?
So and it works with odd as well because odd into odd is also even.
Odd into odd is not even. Odd into odd is odd. Okay, Akrit.
Ha, sir.
Sorry, no, hold on one second, Akrit. But Sana, the formula was b into b minus 2 if b is even. And the formula was b square minus 2b minus 1 if it's odd.
So for odd, it's b minus 1 whole squared, and we know b is odd, so that's why minus 1 it will be even, and an even number squared will always be divisible by 4 because to be even, it needs to have a prime factor of 2, and when you square that, it will obviously become 4.
Exactly. Same logic as before. We write it as b minus 1 whole square. Sana, I see you have a disturbed face. Kya hua?
So, but okay, so B has to be even in the even one, and
Yeah.
B
So
is
we found two different expressions. If b were even, we got this expression. If b was odd, we got this expression. Now my question was, irrespective of whether b is even or odd, prove that this expression or correspondingly this expression is a multiple of 4.
okay.
Correct? That was the question. If b is even, as Arnav said, even times even will be a multiple of 4.
Yeah.
If b is odd, yeah, go ahead, please. And if b is odd, as Akrit was saying,
If it's
this expression
square,
reduces
B,
to b minus 1 whole square, which is even into even. Therefore, it has 4 buried in it.
Yeah.
Either way, it has 4 in it. Does it make sense, guys? All of you. Okay. Okay. One last question. Okay. How many numbers between 1000 and 2000? Let's say, I'll say n is between 1000 and 2000 can be the result of the number of squares that are not in a main diagonal of some square. Okay, I'll repeat that. I'm building multiple layers to this problem now. Okay, so you have some square and you eliminate the two main diagonals, you count the number of white squares, which is what we have been doing for the last 10-15 minutes. Now that number could be any number, right? But not all numbers, right? So if n is such a number, then how many values can n take between 1000 to 2000? I'm not asking specifically which numbers, I'm asking the count of how many. Is the question clear to everyone? Rachit, is the question clear to you?
So can you
No,
repeat the
sir, can you
question?
repeat it once more?
Who can repeat the question for me? Akrit, can you repeat the question?
Yes, sir. So n is the number of so like first you need to know like how without including the main diagonals how many tiles are there, and how many so like how many of those like numbers are there between 1000 and 2000 like without counting those two diagonals.
Does it make sense, guys? So for example, in the 19 wala case, if a 19 by 19 tail, we found the answer was 324 squares were there, which was not in the main diagonal. So, but 324 is not in 1000 to 2000 range. Okay, but there are other numbers in this range. So how many numbers in this range 1000 to 2000, which could be the number of squares that are not in the main diagonal? Is the question super clear to everyone? Sana, you're clear? Snigdha, you're clear? Okay, good. Now get to working. You can chat your answer, Akrit.
So a question.
Yes.
So if a number divisible by 4, is it necessary that it can become like the ones left, because that means it can be divided into equals? So like,
Not necessarily. Just because a number is divisible by 4, I cannot always compose two numbers which are differing by 2, which are multiplying to that, right? I'll give one very simple example. Let's take a number which is 104. How can you write it in the form b times b minus 2? We won't be able to. 104 is divisible by 4. Or why go even that far? We can take something even small. Let's 28. How can we write b into b minus 2? We cannot. Does it answer your question, Akrit?
So I have a question.
Yes, Sana.
So n can be any number between 1000 and 2000.
How many such numbers can n take, which could be the answers to this question?
Okay.
Right? N cannot be any number from 1000 to, but n has the flexibility to be there, but only certain n's will work to be a result of number of squares that are not in the main diagonal of some square. Clear, Sana? Good. Saurabh, you're on it, right? Working on it, right, Saurabh?
So I'm trying to understand what to do first.
Okay, but you understand the question very clearly, right, Saurabh?
Not very clearly.
Okay, did you follow the discussion where the number of squares, we got two different expressions and all that?
Yes, sir.
Followed, and
Yes,
based on
it
whether
will
it's
be
being even or odd, got that
yeah,
also?
yeah.
Okay, so all I'm asking is, okay, so for example, I'll just take some ring. Let's say b is 50. Got an expression, if it's b is even, the number of squares would be, which is not in the main diagonal, will be b square minus 2b, which is b into b minus 2. So 50 into 48. So 2400 will be the number of squares that are not on a main diagonal in a 50 by 50 square. Are you with me, Saurabh? Okay, but 2400 is not a number in this range. In this range, there are few numbers which will fall in this range, which will be result of some other square. Right? So for example, let's say 36. So 36 into 34 will fall in this range. Like that, how many numbers are there in that range? That's all I'm asking. Is this clear, Saurabh?
So 36 and 34 will be counted as one number or two separate numbers?
It will be counted as one number. For a 36 by 36 grid, the number of squares which will not be in the main diagonal will work out to be 36 into 34. Are you with me?
No, sir, I didn't understand.
Okay, if it is a 36 by 36 grid. Okay. Now, so b is 36, correct? So, and we had derived an expression that if b is an even number, the number of squares which will not be in the main diagonal will be 36 square minus 2 times 36, correct? Which is 36 into 34, correct? Okay, which by the way simplifies to, just for ease of calculation, I'm saying 35 plus 1 into 35 minus 1. You should be able to do calculations like this, which is 35 square minus 1. You with me, Saurabh? So which is 1225 minus 1, which is 1224. 1224 is one of the special numbers in the range 1000 to 2000, which could work out. Does this make sense? But 1228 will not, right? So there are only few numbers will work out. How many is the question? Is it clear?
Oh, okay. Yes.
Good. Okay. All right. I see some chats. Sana has messaged me one answer. Okay. I'm not commenting if it's right or wrong yet. Okay. We can start putting on road answers, right? It's been a while. So Sana's answer is 12. Okay. Anyone else agree or disagree with her?
So can I have like 2 more minutes? I'm almost done.
No, 2
2
more minutes.
seconds
बहुत
then.
ज़्यादा हो गया. 45 seconds. Okay. Because already we spent 3 minutes at least since I started this question. This sub
So,
question. Yeah.
So what question are we doing? I had a network issue, so I leave and rejoin. What question are we doing?
We are doing the same thing. 1000 to 2000. How many numbers? That one.
So what exactly do we need to find in that?
Okay. Again, I've repeated it at least twice or thrice. You go and watch the recording. No, please, because I don't want to repeat one more time, please. Okay. I know you had a
Okay, sir.
network. I know you had a network issue, but come back to it, please. Okay. 30 seconds more. Okay. Arnav, buckle up fast. Okay. Akshay, you can call out your answer.
12.
12 as well.
Yeah.
Okay, let's start to discuss, guys. Okay, so even ke liye we have an expression, odd ke liye we have an expression. Let's do the odd, which is b minus 1 whole square, right? Which is the perfect square is just after 1024, which is 32 square. So let me do the odd case. So 33 square will be 1089. You guys, if you know this, that's great. So 33 will work, 35 will work, and all that will work. When do we know how to stop? We know 45 square is 2025. We have been through that method, right? Multiply 4 by the next number, right? If I have 65 square, just to recap, I'll put 25 at the end. I'll multiply 6 by the next number, 6 times 7.
So
42.
even I got 12. So even I got 12.
Okay, good. Okay, so 12 as well. All right. I'm not saying 12 is right just yet, but at least I'm acknowledging that you three got 12. Okay, all right. So 45 square is exceeding. Therefore, for just exceeding. Therefore, we should be safe with 43. So 33 से लेकर 43 तक सब चल जाएगा. Okay, that's for the odd cases. For the even cases, if you do 32 times 30, if b is 30, then that's 960. That's falling short. If you do 34 times 32, that should be fine, right? Because that's 33 plus 1 into 33 minus 1. So it's 33 square minus 1, right? So that'll work. So, and then all the way we can try till 44 times 42. That should work, right? If, okay, if 46 times 44 will not work. If you go to 46 times 44, that'll be very close to 45 square, which will not work. It'll be 2024. But this will 44 will work. So 34 to 44, all even numbers. 33 to 43, all odd numbers. Summarizing, I can count all numbers from 33 all the way till 44, which is indeed 11 plus 1. When you count numbers, you should do the difference plus 1. So 12 indeed is correct. So well done, Sana. Sana was the first one to report this, followed by someone else. Akshaj, was that you?
Yes, sir.
Okay. Okay. Well done. Does it make sense, guys?
Sir, I did it in a very different method. I don't know, maybe if I got lucky or something,
Go ahead.
maybe.
Go ahead, Arnav.
So 1 second, let me just open my book. So what I did it in a similar method, but I got some very different numbers. So I took 46 into 44 and 8 into 6.
8 into 6 कहाँ से?
Sir, 8 into 6, I think, or 8 into, I don't know. So 8 into 6 is 48. I don't know why I took 8 into 6. I don't know. Wait, 1 second. Yeah, must have gotten lucky then. 1 second.
Okay, okay. If you're able to explain what you did, I can explain what you did is right or wrong. But otherwise, I won't be able to comment, right? Okay. Akrit, you had a question?
So can you solve this algebraically?
Can you solve this algebraically?
Yeah.
Yeah, we can.
So I was trying to do that, so I added both. I got an equation, but then I didn't know how do you do it.
Okay, all right. We can algebraically solve this also. See, so we have two expressions, right? One is b square minus 2b. Other one is b square minus 2e plus 1, right? More or less, we're all, so both the expressions are almost same, right? So we can just see approximately both these expressions are same. So I'll just go with one of them, right? I'll just say b square minus 2b. Now I want, in fact, let's go with this, b square minus 2b plus 1, because that's easier. So I'll say, irrespective of whether n is odd or even, let's go with this approximate expression. So b minus 1 whole square should be between 1000 and 2000. Okay, and that's it. So b minus 1 should be between square root of 1000, which is 31.6 something, and then square root of 2000, which is 45 square will be 2025. So 44 point something. So in other words, b must be between, right, less than or equal to, right? So b must be between 43 and change and 31 and change, right? Or 30 and change, is it? 30.6 and change. Okay, so which means b can be from 31, 32 all the way till 43. But then here I'll have to be extra careful, right? So, sorry, I made a mistake here. So b minus 1 should be between 31.6 and 44, means b must be adding 1 to both sides, right? So b must be 45 and change this side, and should be 32.6 and change, right? Whatever. And b being an integer, it can go 33, 34 all the way, 33, 34 all the way till 45. But then always edge cases you have to check, because you cannot be accurate. And then when you check the edge case, you'll see that it cannot be 45. And therefore, it'll go from 33 to 44. Does it make sense, Akrit?
Sir, but like, how can we just ignore the b square minus only 2b? Like, I didn't understand, like, because
So
both will have different ones.
the two expressions are fairly close. They're just off by 1, right? Either b square minus 2b or plus 1. So I'm looking at numbers like 1000 and 2000. So ek do either udhar does not matter much. Anyway, I'm going to do a special test at the far ends once anyway. I'm going to check the boundary conditions once anyway. Like I did 33 and 45, but I checked 45 once by hand. It did not work. I would check 33 by hand. It works. And therefore, I will conclude from 33 to 44. Doesn't make sense, Akrit? You don't seem very convinced.
So it's fine.
Okay. Yeah, but otherwise makes sense, right? Yeah, that's see, not everything will be super perfect. We had edge cases, we have to do some approximation, and right, everything else in between should work safely. Okay, all right. So that was question 5. Question 6 was a little vague. The diagram should have been more precise. Okay. Rachit, did you get an answer on this one?
So I only got to get and finish the question. I didn't get the end.
Okay. Saurabh, how about you?
So for this question, my answer was 4 pi upon 3.
4 pi upon 3.
Yeah.
Okay. Neve, what about you?
Sir, can I recheck my work? I'm not sure.
Okay. I'll give it to someone else. Gyan, what about you?
Sir, I did not get this answer.
Okay. Akshaj, what did you get?
I got 4 root 3 minus 4 pi by 3.
4 root 3 minus 4 pi by 3. Okay, Snigdha. You're on mute, Snigdha.
Sir, I got 2.73.
मतलब no, roots में बताओ ना, otherwise it'll be difficult to check. Root or pi में बताओ. Don't.
So actually,
If you're saying
even
2.73, that means did you use a calculator for the final step? Don't do that, please. If you did.
So even I got 4 root 3 minus 4 pi upon 3.
Okay.
I forgot to say that.
Okay. Saurabh also
Sir,
got
even
this.
I got 4 root
Yeah,
3
same,
minus
even
4
I.
pi by 3.
Okay. And Snigdha, can you just punch in your calculator this expression and see whether you got the same thing? In fact, I want you to guys to call out in terms of pi and roots and all that. Okay. For those who didn't get it, let's just do it. So actually the question should have clarified. This is tangential. Both the arcs are tangential here. So if I just complete it here like this, and if I extend this, if I extend this also here, right?
So that forms an equilateral triangle.
What happens, Snigdha? Equilateral triangle, yes, correct. So this is 60, it's given already, okay? And these two are symmetrical. These two are also symmetrical. So this will be 60, 60, 60. Okay, and this length is given to be 2, 2, 2, 2, 2, 2, right? So the area that we are seeking, which is a beach wala area, is the entire big triangle minus you have two of these arcs. Two of these arcs. So the big triangle is root 3 by 4 into side square. Area of an equilateral triangle is root 3 by 4 into side square. Minus you have these two arcs. Each arc is 1/6 of the full circle. And each circle is pi r square with radius being 2. That's it. So now it simplifies. So this becomes 4 root 3. And this becomes 4 pi by 3. Yeah, Akrit?
I did lots of extra stuff.
You did lots of extra steps. Okay, not needed, right? You agree?
Yes, sir. I made a line ST and then it formed a 30, 60, 90 triangle. So I got I got like 2 for ST and both of those angles are 60, and that's why I didn't just. But
Okay.
how did you get the angle of the arc as 60 degrees?
Okay. Now I wanted to listen to your solution first. So you marked ST, yes, and then?
And then I dropped a perpendicular from U to ST. So then it became a 30, 90, 60 triangle. So that's why that angle is 60 degrees. So and that line is just extended further. So that's why it's an equilateral triangle.
Sorry, which angle is so you're saying? So this is 30. Okay. Okay, and then you're extending this till R.
Yeah, this is 90, and so this is 60.
Yeah, but that 60 is already given to you, right? The upper wala 60 is given to you, and then these two are equal, right? Therefore, it's 60, 60, 60 already, right?
Yeah.
So upper wala is given 60, and this is 2 and 2.
Are given, so that, yeah.
This is 2 and 2. It's given, right? US and UT are of 2 and 2, which means this is isosceles. But isosceles with the upper wala 60 is effectively equilateral.
Yeah.
Therefore, this is 60 is 60. Okay. Continue further. After that, what did you do?
After that, I found ST. But before that, I found ST because like the half point is 1 because it's 30, 60, 90, and then I double that, I've got 2.
Yeah.
And yeah. Then I found out that is unnecessary, and then I found out both the side lengths because it was 60 degrees, and the bottom two radiuses are 2, and since it's equilateral, even the other sides are 4, and then I just subtracted like that.
Okay, no, but I didn't fully understand your method. So you have upper wala triangle, and then how do you find the shaded area?
So same thing, I did a little unnecessary stuff in the middle.
Okay, all right. So basically he's saying TR and SR are each 1/6 of the circle of radius 2. So this will be a radius 2, this will get completed, right? So this is 60 degree or 1/6. All of you clear on this method, guys? 4 root 3 by 4 by 3, easy, right? Fairly. Okay. Let's see. I'll just give you, can you guys find the perimeter of USRT, please, in terms of pi? find the perimeter of the same picture. Akrit, can you delete your working? Because I'm not able to. Beach wala jo red mein. Yeah. Find the perimeter, guys. Fatafat. Yeah, Akshaj, go ahead.
4 plus 4 by 3.
4 plus 4 pi by 3. Okay, let's check. It's easy only. So 2, 2.
Sir, I got 4 plus 2 pi by 3.
4 plus 2 pi by 3. Okay. All right, let's check. So this is 2. Yeah. One other answer, Akrit.
So 4 plus 4 pi by 3.
Okay, so 2 people this, 1 person this. Okay, so 2 is 4. And then this one is 2 pi r into 1/6. So 1/6 of 2 pi r. R is given to be 2. And there are 2 of them. Therefore, into 2. So it's indeed 4 pi by 3 is what you have to add. Does it make sense? So whoever did this probably forgot to multiply the by 2, right? Okay. That was question 6. Question 7. Yeah. Neve, were you able to do this one?
I tried, but I couldn't find the answer for this.
Okay. Let's see. Akshaj.
So, sir, I started it a bit, but then I didn't get it.
Okay. Any answers, guys? Anyone?
Sir, I got
10 by 5.
Sir, I did it, but my notebook is so messy, I can't find the answer.
That's not my problem, beta. You have to figure it out. Okay. Okay.
12 by
Sir, I got the answer 4 units.
4. Okay. Gyan says it's 4. And Akrit, what were you saying?
Sir, I got
12 by 5.
12 by 5. Okay. One other answer. Someone was
Sir,
calling
I
out.
think I got something like 4 by, no, wait, 1 second. I got, oh no, I can't find it.
Okay. Again, not my problem. It's very important to have your workings all clear, guys. I mean, it's not just for my class. Being organized is extremely important in life. Okay. You have to cultivate that habit right now. Otherwise, this habit will continue. Okay. Right now, Arnav is the hearing side from me, but applies to everyone. Get organized. Spend time in getting organized. I've generally found girls are more organized than boys. Okay. But please, it should not be gender dependent. Please work on, have a separate notebook for this class. Print out everything and keep.
So I just found it. So I just found it.
Okay, you might have just found it, but I'm just saying the message is common message. And for, okay, go ahead. What's your answer, Arnav?
But even I got 12 by 5.
Okay, 12 by 5. Okay, let's do it quickly, right? They have equal perimeters. Okay, so matlab, let me just randomly draw, let's say this line is somewhere here, right? So these two have same perimeters. So let's say this portion is x, then this portion is 5 minus x. If the two perimeters are same, then what are we saying? We are saying 3 plus x plus, let's say this common is y.
So, but can't we just directly find how the split will be?
Yes.
In CB?
Yes, go ahead, please. How will you split? Differ by
so if we take the line which is crossing as like x,
yeah.
So then that will be same for both triangles.
Correct.
And for both parameters to be equal, that means that 5 will be split into 3 and 2.
Exactly.
So it will be,
yeah. That's exactly what I'm doing. I'm just writing it formally. That's it. You're absolutely right. The common portion I called as y. Y will anyway cancel out. And 4 is 1 more than 3. And therefore 5 minus x should be 1 less than x. Right? So whatever way you do, you can easily get that this is 3 and this is 2. That's what you also got, Snigdha. That's what you're trying to say, right? Since 3 and 4 differ by 1, compensating for it, this portion should be longer, this portion should be shorter. So this will be 3, this will be 2. Right, Snigdha? That's what you're saying, right?
Yes, so.
Okay. And what is the area of triangle? ABD. D kaun sa hai? A. This is ABD. Okay. All right. Who can complete this? Arnav, can you complete how you got 12 by 5 from here?
Yes, sir. So 3 plus x is equals to 4. So 1 second. I don't think I did it this way.
No. So you might have gotten this step in a different way. Doesn't matter. Right now we have got this as 3 and this is 2. From here, what should we do? Tell me.
Yeah, so I got half into 6 by 5. 1 second.
Okay, I'll pass it on to someone else.
Mhm.
Sana, were you able to get from here? Continue from here.
Yes, so I just remembered how I did it.
Okay, Arnav, go ahead.
So I use similarity again.
Okay.
So I got height is to 3.
Okay, you drew which height? From D, you draw the vertical height, is it? Like
Yeah,
this?
no, so basically your AD only, your AD.
Okay, sure. The green line that I drew, should I erase it? Not needed for you?
1 second, sir. 1 second, I'm just forgetting how I did it. 1 second. No, yeah, no, I think that line should be. No, so yeah, you can remove the green line, I think.
Okay, continue.
Okay, so I think AD, so like Y, okay, let's take Y. So half, so what I did was half into, no, so height is to 3 is in proportion to 5 is to 6 is to 2. 1 second. So 1 second, can I just revise how I did it?
Okay, revise how you did it. I'll call out your answer also afterwards. But meanwhile, Sana, can you go ahead with your method? What did you do from here, Sana?
So so that equation you just written, I don't know where it is now, but if you solve it, I got the answer as x equals to 2 at the end, but I
Yeah,
don't.
the x equal to 2 is your length for BD.
Yeah.
You got your BD length as 2 and therefore CD length is 3. But after this, what?
After that, you can so if you multiply the two, 3 times 3 is 9 and 2 times 4 is 6, and 9 and 6.
So I don't understand. What do you mean 3 times 3 and 4 times 2?
To find the areas of the two separate triangles.
Yeah, but why would you multiply 4 times 2? 2 is not perpendicular to 4, right?
Oh, hold on. I was thinking about it in a really different way. I took the question in a different manner.
Okay.
But I think I've got an idea of how I did it now.
Okay, go ahead, Akrit.
So I'm not. Okay.
Oh, sorry, Arnab. Sorry, I didn't hear you. Arnab, I'll come back to you. Akrit, go ahead.
We can just use what you said before. So half into 4 into 3. So that will become 3 into 2, 6. So that's the area of the triangle. Now that then is equal to half into 5 into the height. So that's how you get 12 by 5 at the height. And then once you get 12 by 5 at the height, you know the base is 2. It doesn't matter because so I'll draw.
Yeah.
Even if it's like this, it's still the height because it's still 90 degree and it's still like hitting here. So this is 12 by 5, half into 2 into 12 by 5, so 12 by 5.
Understood. But you can do it shorter. I'll explain it to you in just a second. Can you erase the red line?
So I have a question.
Yeah, go ahead, Sana. Yes.
Okay. So basically, if you is CAB a 90-degree angle?
Is CAB a 90-degree angle? You tell me. The lengths are given as 3, 4, and 5.
Yeah. Okay.
It is, right? Because the lengths are given as 3, 4, and 5. Okay. All right. So just to explain what Akrit did. Okay. So we agree on the length of 3 and 2, right? From here. So if I drop a perpendicular from A to BC, okay. So now if I tilt my eyes and then focus with BC being the flat line, this becomes the height, correct? So this becomes the height. Okay. So
wait, so angle CAB is a 90-degree angle?
Yeah, because they're 3, 4, and 5, right? It's given.
Oh,
and that's
oh,
what
yeah.
you infer. It's first thing you should infer is that. Right? Now, what Akrit did was a slightly longer method, but still I'll go through what he did, and then I'll come to how we can simplify this even further. So the height, as we just saw in a in any right angle triangle, just to recap, if I have any right angle triangle, if I call this length as A and this length as B, then this height would be AB upon C, and C is square root of A square plus B square, right? So in this case, the height H would be 3 into 4 by square root of 3 square plus 4 square, which is 12 by 5. But the same 12 by 5 is the height for the triangle ADC as well as for the triangle ADB. If I keep DC as the base or DB as the base, if I keep DB as the base, then it looks like this. It looks like this, right? But the height is falling outside, but does not matter. The height is still the height. So the area just becomes, the area that we are seeking is just half into the base, which is 2, into the height, which is 12 by 5. Does it make sense, guys?
So I didn't understand how you got AB by root of A square plus B square.
We did that, you remember, in a right angle triangle, the height H is, we said area is half into A into B. We also said the area is half into C into H.
Yeah.
Okay, I'll write it as AB by C if that helps. But C is your A square plus B square ka root. So using this, we get H equal to AB by C.
Yeah. Okay.
At the beginning of the class itself, we did this. Is everyone clear on this, guys? All of you clear on this one? Sana, you're okay?
Yes, sir. But does the rule that we covered in which the height okay, so the height for CDA and CAB is the same, and that's why it works.
Exactly, right? So in CAD, the height falls within the triangle.
Yeah.
In ADB, the height falls outside the triangle, but
Yeah.
the height is still the same
Still
height.
the same. Okay.
Okay. Now the only other optimization I'll do on what Akrit covered is I don't even need to know what this height is. Okay. So I'll erase all of this. I will say the area of the full triangle. Full triangle ka area kitna hai? We know half into 3 into 4.
You can
Right?
just
Which is
divide it by 2.
6.
2/5 of that. So wait, the area of the full triangle is 6, right? Half into 3 into 4 just by base into height, just half into 3 into 4. Not this height, not the H height, but 3 as the height and 4 as the base. It's 6. So no matter which way I look at it, it's 6. Now if I tilt my eyes, if I compare the ratios of this triangle ADC versus the triangle that we are seeking ADB, then the heights we know are same. We don't care what that height is. The ratio of the areas will just be the ratio of the two bases. The ratio of the areas will be therefore 3 parts is to 2 part. Do you agree? So all we have to do is split this 6 in the ratio 2 is to 3. This area 6 is, so the area that I'm corresponding to 2 is 2/5 of the entire area. Bas, matter khatam.
So, but won't the areas be like square? The ratio of the areas be squared?
No, they are not similar triangles. They are two triangles with the same height but different bases. What you are saying is there are two similar triangles, then the ratio will be the scale factor square. Here the two triangles ADC and ADP are not similar. They have different bases but the same height. Are you with me?
What ratio is 2:3?
The ratio of the two bases.
No, like that is fine, but like what else?
And the heights are same. And therefore the areas of the two will be in the ratio 2:3. No?
Oh, because the height of them is same, and it's the base, so like the only thing left is the bases will change the thing. Okay.
Exactly. And I'm saving the step of calculating the height. I'm being lazy. I don't want to calculate height. I don't need it. I like to be lazy. Does it make sense, guys? Yes, I can do it, but no, I don't want to do it. Does it make sense? All of you, both methods?
So can you repeat this method again?
Not me, but Snigdha will repeat because she said yes, she understood. Go ahead, Snigdha. All yours.
Yes, sir. So basically in this, the height would be same. So instead of figuring out the height and then taking the ratio, we can just directly take the ratio. Like if we take the height as x, in the ratio will be like 3 by x is to 2 by x. So it's basically the ratio is 3 is to 2, and then we have to divide the area and the ratio 3 is to 2.
Not a good explanation, Snigdha. You could have done better. Let me pass it on to someone else who can explain it better. Rachit, can you try?
Okay, sir. The total area of the triangle ABC.
So, okay, the goal is Neeb should say he got it. That's the proof. Okay, go ahead, Rachit. Yours.
So the total area of the triangle ABC is 6.
Pause there for a second. Neeb, do you agree on that one?
Yeah.
Okay, continue.
So the ratio of the bases of ADC and ABD is 3:2.
Do you agree?
And since the height,
Rachit, you have to pause and ask him. Does he agree? Ask him. Does he agree?
Yeah, I agree.
Okay.
since the height of both the triangles is same, therefore the ratio of the areas of both the triangles will also be the same ratio of 3:2.
Yeah.
So therefore you have to divide 6 into 5 parts in the ratio 3:2, with ADC getting 3 parts and ABD getting 2 parts. So
Very well explained. Yes,
Yeah.
Rachit. Okay. Does it make sense, Neeb? Yeah.
Yeah,
Snigdha,
I've got
I'm
it
sure you
now.
got it. I understood your explanation, but Neeb did not. I could see it from his face, which is why we should pause every. Now, whenever I'm asking, I'll continue. I'll keep doing this. When someone asks, I'll ask someone else in class to explain. That way, it reinforces for you guys also, whoever is asked to explain, and you should pause and explain until the other person actually understood. Right? Challenge that person whether he understood till that step, and take it forward. Okay. Okay. Good class. We count of problems we did 3 or 4, but then in each of them we went into a variety of different dimensions. Okay, please watch the recording, guys. Some of it might not be clear in the first pass. When you go through it again, it'll stick in better. So please do that, and I'll send another homework. We are still in the first homework, I think, right? Didn't even finish this, but that's fine. We'll go a little faster in the next one. Okay, chalo, bye.
Bye, sir. Thank you.